Hello, Calculus. It's the 24th, so this is the Friday, Saturday, Sunday edition. So I'm going to explore the connection between the Riemann sum and the definite integral. And we've kind of discussed this, but I just want to hone in on it a little clearer, more precise. So let me observe this graph and observe it with me. Notice that the function and from A to B are as normal, but the partitions, the actual subintervals, have various widths. These in here are quite thin, and this looks like the fattest one right here. Well, this is not unusual, and we saw it some when we were working with Riemann sums on our charts that were charted values. But some of the subintervals had different widths than others, and that is not okay. In fact, it's the norm. In fact, we call the width of each subinterval delta, and we call the width of the largest subinterval the norm, and we indicate it with these double bars. So it is the width of the widest subinterval. So I marked it on here. That is our delta in bars, and it's red, the norm. So from here we can see that we can actually redefine our Riemann sum as we let this go to what value? As n increases, even though they're different widths, as n increases, nonetheless, what happens to the width of this norm as n increases? As the number of subintervals increase, that norm, can you foresee what it's going to be? As n goes to infinity, what happens to the norm? As n goes to infinity, the norm will always go to 0. So this is how we will think of it, and as the norm goes to 0, n goes to infinity. So it's kind of odd how we state that, and it looks like this. If n is defined on the interval ab, so we have a function, we used to say the limit as n goes to infinity. But now we replace that with an equivalent statement that the norm goes to 0 as I goes from 1 to n. This statement infers that n is still going to infinity. Alright, so notice that new and improved definition. So if that's true, then the function is integrable. In other words, you can take the integral of it, and we have now learned the fundamental theorem that this limit, as the norm goes to 0, we have more and more subintervals until we have an infinite number. It's the same as the definite integral. And we brought that to light on our last video, and we even defined how to calculate that. And that is called the definite integral. Again, I mentioned from A to B, and A is called the lower limit of integration, and B is called the upper limit of integration. So if I have to refer to those numbers, that's how I will do it. Alright, so I want to make a point here that I want you to be able to practically recognize one of these and be able to write it, one of these and be able to write it like one of these. For example, suppose I say this: the limit as the norm goes to 0 of the summation I goes from 1 to n of 3 times sum c sub I plus 10 times change of x sub I on the interval from -1 to 5. So can you give me the definite integral that this is representing? So here is here's the general form right here. And notice this whole expression here is actually telling us what the function is. It shows us what the function did to the c sub I, and it tells us what the variable is, and it tells us on what interval. So here is what you should be able to observe from that. It is equal to the integral from here to here, a to b, lower limit of integration, upper limit of integration, and the function following the integral sign is hidden in here, and it's 3x plus 10, and the change of x will go to dx, which is a representation of the width of the box in infinity. It goes to a very, very thin, infinitesimally thin width, and we're going to represent that with dx. The dx also tells us what the variable in the problem is. All right, so just wanted to point that out. It'll become helpful in some of your exercises. All right, another observation is that a definite integral is a number. And we were practicing on Friday doing many definite integrals, and each one came out to be a number. So a number can be positive, it can be negative, and it can be 0. So I'm moving away, but not totally away, from the idea that the integral is an area under a curve. Because area makes no sense when I come up with a negative number or even a 0. So I just want you to be aware that integrals can be positive and negative, and in that case the area, the way we talk about it as area, will have to be refined, and we'll get to that eventually. So let's look at one that might not be positive. So what is the integral of 2x dx? Well, we learned how to take the integral using our new best friend, x to the n dx is x to the n plus 1 over n plus 1 plus a constant c. Alright, so when I take the integral of 2x, the 2 will come across the integral sign, and we'll pull that out later. We'll leave it right in front, but then we integrate x dx. Following this form, x is to the 1. I increase it by 1 and divide by that new number.